Hello students, welcome to the first problem solving session for chemistry paper 2 of IIT JEE 2010. So students, we have solved the questions of chemistry paper 1 of 2010. Now we will be solving the questions of paper 2. So students, the questions were so easy in the chemistry part of your IIT JEE 2010 that without preparation you can attain a very good score. They were very simple questions, right? Now here also in the paper 2 the questions were too simple, so we'll quickly discuss all those questions. Okay, now let's start our problem solving session, students. See, here was one of the questions. Now you must be aware of that the IIT JEE paper has got 4 sections. That is, your first section is of multiple choice, only one option correct. The second section of in this paper particularly is of the integer type questions, that is you have to solve, and the third section is of the paragraph type. The fourth is of either the matrix match or the multiple choice, more than one option correct. So students, this section is of multiple choice, one option correct. Now the question here is the compounds P, Q and S, these are given as here, were separately subjected to nitration using HNO3H2SO4 mixture. The major product formed in each case respectively is. So students, before looking on to the options, just try to find out that what type of reaction it is, whether it's an electrophilic substitution or the nucleophilic substitution. Now it is the benzene ring, so what type of substitution is going to take place here? It will be an electrophilic substitution reaction. Right? Now what will be the electrophile here, students? In this case, when you are taking the HNO3, that is concentrated nitric acid, and H2SO4 mixture, the electrophile which is generated is nitronium ion. Right? So this is the attacking species. Now students, this nitronium has to be substituted in your P, Q and S. Now let's take up P. So what all are the groups present in P? What is it, students? It is methyl group, right? So there is what? There is CH3 group. Now what type of effect it has? It has got a plus I effect, or it is a plus I effect group, right? So as it is a plus I effect group means what? Here there is a mistake. This is not a CH3 group, this is an OH group. There was some printing mistake over there. It is OH group. Right? Now, what is your OH group? OH group is an activating group or a deactivating group. Your OH, due to the presence of lone pair of electrons on the oxygen, is a ring activating group. Right? So where all the substitutions will take place? At ortho and para. But there is another group which is COOH. So this OH has got your plus M effect, and COOH is what? It is a ring deactivating group, right? So it is a ring deactivating group. So where the substitution will take place? It will take place at its meta position. So where will you expect your NO2 plus to be? At P, right? So here you will have your NO2 plus, right? That is here. So you have solved your first option. This is here. This is the ortho position and this is the meta position for COOH. Your first is solved. Then coming to the next. Now students, your CH3 is what? CH3 has got plus I effect. That is, it is an electron releasing group. But is there any mesomeric effect over here? No. What about OCH3? Now your OCH3 has got what? Lone pair of electrons also with oxygen, right? It is present in this position, so it is also an ortho para directing group. So both are what? Both are ring activating groups. This is for P and this is for Q. So your both the groups, that is CH3 and OCH3, both are what? Both are ring activating groups, right? But which will have the maximum effect? Which is going to have the maximum effect? Your OCH3, right? So where the substitution will take place? At ortho position to OCH3, that is here, right? Is my point clear? Now let's take up the S1. Now see students, here in this case, to one ring there is a carbonyl group bonded, right? Now this is again a ring deactivating group. Why? Because oxygen being more electronegative takes up electron of this double bond. There is a slight positive charge created here at the carbon atom, so the electrons, they move out. So will the nitronium substitution take place here? No. Nitronium substitution will take place here, right? Now at again your ortho para position, so it will not take place here, it will take place here. At the, this is what? This is, there will be steric hindrance. So here meta, it's not possible, and this is para. So here nitro substitution will take place, right? So what is it, the name of this compound, students? It would be, let's start numbering it, 1, 2, 3, 4, 5 and 6. The compound will be named as benzoic acid. So it is 4-hydroxy 5-nitro benzoic acid. Likewise there will be methoxy, right? And this is another group, that is acid, COO. This is an ester, right? Now let's see which option is correct. Do we have it here? NO2 is here, but NO2 substitution has to take place at this position, right? So this is wrong. In this case, no, this is also wrong. Let's see the C option. The NO2 is here, the NO2 is here and here. So our right option is C. So students, this was a very, very easy question. You just need to analyze whenever you are writing or solving a question related to the substitutions in the benzene ring. What is required is you just try to analyze what all groups are present, what is their effect, and remember one thing. Whenever there is your I effect as well as your mesomeric effect, which effect dominates? It is the mesomeric effect, right? Now let's take up the next question. This was actually